In Creo 10.0, we have added the capability in Creo Ansys Simulation Advanced to solve for some nonlinear materials. The three types of new materials are neo-hookean hyperelasticity, linear orthotropic elasticity, and bilinear plasticity. Let's take a look at two of these materials, starting with the bilinear elasticity first. Taking this assembly into Creo Ansys, we have two components that are defined with nonlinear properties. The plate components have a material defined with the linear hardening law, and you need to provide a tangent modulus and a yield stress for this material. After this is defined, the solver will identify this material during the solve and provide the appropriate response. This assembly has been defined with a number of contacts between components and also has boundary conditions for the setup already defined. We are applying a large force, pulling this beam away from the bolted plates. Let's click on Run and start the simulation. After a few minutes, we can now review a few results. Let's first review the von Mises stress for this assembly and look at the deformations. You can clearly see that the plates have plastically deformed based on the view on the screen and knowing that these plates are made of steel. You can also see from the equivalent plastic strain where the permanently distorted locations of the plate are located. Here I'm only showing one of the plates. And finally, we can verify what type of deflection has occurred. With this new type of bilinear hardening, you can solve many types of simulations where plasticity of the materials is involved. Next, let's take a look at the neo-hookean hyperelasticity materials now included in the Creo Ansys Simulation Advanced package. Here I have an automotive rubber boot model. Let's take a look at the material assignment we have for this in Creo Ansys. You can see how we have defined this material with a stress-strain relationship as hyperelastic and used a neo-hookean model defined with the appropriate parameters to define this material. Again, when you have these material properties defined up front, the solver will respond during the solve. For the setup in this analysis, we're going to hold the boot fixed on the bottom and enforce a displacement of 20 millimeters to the top of the boot. We then click on Run and start the simulation. After a few minutes, we have our results. First, let's review the displacement. You can see the auto scale and also the true scale, and then animate the results. Next, we can review the von Mises stress results and see the amount of stress for the simulation is very low. And lastly, we can look at the equivalent elastic strain, which is the reversible distortion of this analysis. The new nonlinear material capabilities in Creo Ansys provides a big step in solving more complex simulations and adding more value to our customers.